Today we're going to build what's known as a candle heater, typically used in small greenhouses. Design that is really put out a lot. What I consider major problems with this. First of all, you'll notice the height. The distance here allows a lot of airflow. The airflow can come through and blow your candles out. Condensation can run down the side, splatter, and if your candles are not properly underneath, it'll run on the edge, drip down, and put your candle out. A lot of issues with this particular point. Also, you've got to have what is not mentioned in their setup. You're going to have wrenches to put these on. You're going to have a cutting wheel, a hacksaw, or something to cut the threaded rod. Next issue is cleaning. Because the candles are sitting at the bottom, the idea is that they're going to go through, catch underneath here and heat this, and go underneath here and heat this, and you've got a double heated layer. Again, your dilemma is, if you look at that, that's sealed off at the top. You have nowhere for that smoke and so on to go. That means this area is going to get built up with soot really quickly, especially if you're using those little whatever they call them, candle things there. So you're going to have to be taking this on and off quite a bit in order to clean that and clean underneath here, and in doing so you're going to run a risk of it breaking. And you've got downtime. You've got to let it cool off so you can handle it, because when the metal is warm it's going to expand. That's going to be another problem. The expanding metal in and out can cause cracking. You're going to have a drill and a bit properly to drill this hole down here, and if you do it wrong, this whole thing is going to break, shatter, chip, whatever. So you've got a drill bit, some kind of cutting utensil, wrenches to tighten these. If you tighten it too tight at any given time, this fractures. You drill wrong, it fractures. Taking it on and off, it can break. Soot buildup. Soot can become extremely flammable, as in why you've got chimney fires. The resins and stuff that builds up with the soot in the chimneys, and as such, it's a pain in the dupa. Again, you're going to have to use 3 or 4 of these little guys. They're going to burn out fairly quickly within an hour or so. And so you're going to always have to be running outside and changing these. So long term, that is a big expenditure. Because you're paying a lot of money for that little aluminum cover there. You're going to need 6 items. A bottom, little terracotta, they call them feet, an inner pot. You notice my inner pot has no raised ridge. There's a purpose for that. An outer pot with a raised ridge, and then this is actually another bottom but a real small one, and a candle. The way that this goes, you put down your pot, you lay down 3 of your feet and space them. and I mean here you could actually like use a little bit of super glue or something so they're always held in the same position once you get them properly. Your candle would go, you'd set the inner pot on it. Your second set of feet, there's 6 total. They come 3 in a package. I didn't, they're not flat. You see how these are flat? These are turned on their side. It raises it even higher. So now I've got that lipless underneath where the heat's going to come through and dissipate up. And this extra rim gives more spacing. Underside gives good airflow, but not so much airflow that the candle could be easily blown out or water drip on it and knock it out. And then the second little, which is actually a bottom, which is your top cap. Now the way that this works, your candle is burning inside here. It's going to heat this pot and this hole is open, unlike the other design where that hole is closed. This allows the hot air to come in, but because this cap is here, it has nowhere to go. So it expands and comes down the side. So now I'm heating this twice, and I'm heating this once. That means it's going to use less amount of energy to heat and retain the heat longer. Because of my spacing and height, it allows that hot air then to come down and dissipate out while causing a convection, pulling cooler air in from the bottom. So it rises, curls, comes out, the cooler air comes in, heats, rises, curls, comes out. If I need to blow a candle out, I simply slide this to the side and I can blow the candle out, or I can slide it and see if my candle is still burning. Put this back into place. Nothing can drip down into it, blow it out, or whatever. That's the basic concept in itself. So now let's see how it is put together.
We're going to be using some basic components. 2 terracotta pots, a base, a candle, a smaller base, and 2 packages of these. There'll be pictures with all of the numbers and everything. I got all of this at Obi. So the first thing we're going to do is I'm going to be doing this with a single hand. We're going to take our bottom and we're going to put it there. We're going to take 1 pack of these little scunchies. That's what they look like. And that's going to raise the outside, lower the inside. They've got a little dip to hold the pot. And I'm going to move these all the way out to the edge and try to center them. I mean, you could use 4, but they come 3 in a package, so that's what I'm using. And there you see. Okay. Boom, that's done. Now, what I want to do now that I've got that centered is I'm going to go ahead and just put my candle right there. So I've got my candle. That's there. The next thing is I need to raise. What I want to do is have the hot air come in here, have nowhere to go, come down the sides and come back around, heating the outer one as well as the inner one. So we've got an insulation thermal layer that's coming out, as well as enough space for cool air to come in, causing a convection flow. So we're going to take another set of these, and instead of setting them flat like this, we're going to turn them sideways. And I want the big piece here on the inside, so I've got maximum amount of surface tension out here. And now I can realign my center pot so that I've got that more or less centered. Mind you, I'm doing this with 1 hand. The second pot's going to go on top of this and sit right on top of these connectors. A nice firm base all the way around. There we go. Now, at this point I have cold air coming in, fresh air. It's going to suck into the candle. The candle's going to be lit. I've got a gap right here, and the opening in here that's going to allow that hot air to come out and rise up. Okay? And the last thing, to keep any condensation from dripping down into my hole and dropping the candle, and to close off the loop, I'm going to have one of those. Now as the heat builds up, it's going to want to come down, it's going to want to escape, but as it builds up in here, it's going to be heating the inside quicker because the heat's retaining longer in and out. It's going to vent out, the cool air is going to come in, it's going to power the candle, and then when I want to clean it, when the candle goes out, I can look in, I can see if my candle is still burning. If it's not, it's out. Then I can take this, take it off, I can clean any soot out of either one, replace my candle, put it back on, and we're off and running for the next one. That simple. It conveys a larger conductivity, it holds a higher heat retention, and because you don't have that big wide gap onto those little candles, this candle is burning slower, it will last longer. I've calculated one of these candles should last about 2 days. I could be wrong. This is a new build. I'm going to test it, and then I'll let you know how long it lasts at the end of the video. It is 3 degrees Celsius outside. Now, it must be stressed here, this pool stays an average of 26 to 27 Celsius at all times. So it's going to add some heat, and as you can tell, a lot of moisture. It keeps things in here almost at a high humidity level, so the plants really like it. But currently, the temperature is at almost 12 degrees Celsius. That means there is, what, a 9-degree temperature difference? I'm calculating each of these will put out at least 1 to 1.5 degrees temperature increase per pot. So 4 pots, that's 6 degrees.
On a final note as well, the airflow is really even. There's no flickering. So that means the candle is not producing as much soot as the other design where it's open to the air. So that's another plus on that one.